Okay, let's go ahead and tackle the problem in example 4.4. So the first thing I want you to do is go ahead and read the problem statement that's here on the screen. And when you're doing that, go ahead and pause the video. And after you finished reading it, just go ahead and absorb everything, make sure you understand what's being asked. And then when you're done, go ahead and press the play button and we'll continue from there. Now that you've read the problem statement, let's go ahead and find what the goal of the problem is. What exactly is it that we want to find here? So from the problem statement, I think it seems pretty explicit here. Just right in the first sentence, we want to find the height from which we would need to jump so that when we were to land on the ground, we would land at a speed of 35 miles per hour. And that's all that's being asked for here. So in order to achieve this goal of finding the height that we would need to jump from, what exactly do we need to do that? What kind of information are we given from the problem statement to help us do that? Well, the problem statement is pretty short, as you may have noticed, and really there's only one piece of information that we have, and that piece of information is the 35 miles per hour that we would be hitting. There isn't a whole lot there, but why don't we just go ahead and assume that we have no air drag in this problem to make our lives a little bit easier. Let's go ahead and think about what kind of equations we would need to solve this problem. Now, I know that this is in the energy section. Now I think we're ready to move on to the solution phase here. Really all I have is a kinetic energy at state 2 and a potential energy at state 1. I just have to find those individual terms, plug them into equation 1, and rearrange and solve for H1. So let's go ahead and do that. So the kinetic energy for state 2 we can write as 1/2 times the mass of this person jumping off the building times V2 squared. Likewise, the potential energy for state 1, it's all gravitational potential because I have no springs involved here. So that would mean it's just the... Okay, so we finished solving the problem. We could end here, or what we could do is we could check our answer. And there are two ways that you can check an answer. One is just to ask yourself, does